Merge two sorted list. You are given the heads of two sorted list, list 1 and list 2. Merge the two lists in one sorted list. The list should be made by splicing together the nodes of first two lists. Return the head of the merged linked list. So basically the question is asking us to return one linked list which is in an ordered format, which is in a sorted format. They have given us, if you see the question, they have given us L1 and they have given us L2. These are the two linked lists which they have given us, and the question is asking to merge this two linked list. Let's just have a conceptual review of linked list in just a minute. That if you see, every linked list is linked with the references or with the next nodes, and every linked list has a head and tail, wherein head is at the first of the list node and tail comes at the end of the list node, and tail points towards null, which shows that linked list end over there. Head, with the help of the head, you can find any value of the linked list because it is a reference. So you can, if this is 1 2 3 4, and you have to understand, you have to go to 3, then you just have to traverse with the help of head by saying head equal to head dot next, head equal to head dot next, and come to this particular node. So this is just a concept which I told you about the linked list, that it consists of a head and tail, and tail is pointing towards null. Now let's see what is this question asking for from us. They have given us L1 and L2. Let's assume that this is L1 and L2, and they are asking us to merge this two list. Now, how are we going to merge this? They are not asking to do a different list. They are asking to solve this in O of n plus m. That is, this is a length. What is n plus m, right? So length of L1 linked list is n, and length of second linked list, that is L2, is m. So they just want in a O of n plus m time complexity. So they want this linked list to be merged in place, and they don't want it to create a different linked list. Let's see how to do this. So, a naive approach, or the first approach usually to solve such problems, is we know that this linked list are sorted. We can take an advantage of this particular sorted linked list. To start with it, we have to check whether the heads of both the nodes, which head is smallest. Okay, in this case, if you see, is L, we can write like if L1 is smaller than equal to L2, if this is the case, if L1 is less than L2, then we are going to point our head towards L1. Is this step you're getting what I'm trying to say? When these two lists, you are taking L1 and L2, we are checking, is the L1 less than L2 or is L1 equal to L2? Whatever is the case, we are going to make head as L1. So now, the because of this particular statement, because of L1 less than L2, if L1 is less than equal to L2, then head becoming L1. So now our list becomes, first list is having the head as L1. This is the L1. Now next comes this 2, and this is 1, right? I mean, so this we have given to head, right? This pointer we have given to our head, right? Now the next L1 is now consisting of 2 and 4, and L2 is still consisting of 1, 3, and 4. Again, we are going to ask the same question, if L1 is less than L2, and at that time we'll get answer as no. L2 is greater, right? L1 is greater, right? You see the L1 value? L1 value here it is 2, and L2 value here it is 1. So L1 in this situation, L1 is greater than L2. So we cannot take L1's value. We have to take the L2's value. So next comes our L2's value and we are joining that linked list. We are referencing that linked list. Now the L2 is also gone. Now again start with the same algorithm which I said. If L1 is less than L2, then head equal to L1. Check, the L1 is having 2 and L2 is having 3. Which is less? L1 is less. So again we are going to take this 2, we are going to take this L1 and going to reference it to our linked list. Right? We are going to reference this to our linked list. So now our L1 consists of only one node, that is 4, and L2 consists of 3 and 4. Now again ask the same question, is L1 less than equal to L2? No, in this time L1 is having value of 4 and L2 is having value of 3, which is less than L1. So we are going to again reference it with L2. And then there are only two nodes which are pending and both are having same value. So you can reference it as 4 or 4. It doesn't matter who comes first. This is the way we are going to give the same as an our answer. If you see 1 1 1 1 2 3 2 3 and 4 4 4 4. This is a naive approach which I showed you by showing and comparing each nodes of the list node together. This is the basic formula. We are basically checking whether the value of L1 is less than equal to L2 or not. If the value is less, then we are considering that as our first list node. And this we are exactly doing in O of n plus m time complexity. Let me show you another way of doing this. Same thing we are going to recursively call, or we are going to solve it in a sub problems. Let's try to understand that approach as well. As shown, we have given L1 and we have given L2, right? Same formula we are going to say, if L1 is less than L2, then head becomes L1, else, else, what is the else condition? Else our head is L2, else our head is L2, right? This is the condition. So first step remains the same and we are considering 1 as our head. Now in the next step, so this has gone as I have shown, it is the same first step. In the next step we have 2 4 and 1 3 4. So what we are doing, we are not comparing each node now. What we will be doing is we will be calling our this particular function. This is a function of merge two sorted linked list, right? This is a function. We are going to call the same function for both of this particular list, and then we are going to merge this as 1, this is 1 2 3 4 and 4. Now this became a sub problem which merged this list in the head. In this particular head we merged it, and now we are going to reference this head to this particular linked list. So basically we didn't compare each linked list, each list node. What we did, we solved the sub problem. We just solved this particular sub problem. We merged this sub problem, and whatever the merged linked list is there, we again merged it with our original linked list. That is called as merged two sorted linked list, and this is O of n plus time n O of n plus m time complexity. And this is called as a recursive approach, wherein we are using the same function again to the two list nodes. This is again L1 list node and this is again L2 list node. So we are using this particular function. This is a merge to sorted function. we are using this function again to the sub problems, and then using that sub, when the sub problem is solved, we are using this particular sub problem and referencing it to our original linked list. Sorry, not as this is the way, and referencing to our original linked list. And at the end, we will be returning this particular head. And at the end, we are returning the head which is from 1. So it will give us entire linked list. So it will give us the entire linked list. Hope you guys have understood what I'm trying to say here. This is a recursive approach. So whatever function I am writing over here for the first node, I will be writing the same function for this two linked list. I'll solve this problem first. I'll solve this sub problem first, and then try to solve the entire problem, which is called as a recursive approach. And this time complexity is O of n plus m, and space is also n plus m. Let's see the code. Public static, public static, list node, merge to sorted list, list node L1, list node L2. These are the two lists given, and as I said, I'm going to write the same function. If L1 dot val is less than equal to L2 dot val, then what I'm going to do that I have to write it. But before that, I'm going to initialize my node, list node, that is head. This is a variable. Now, when this L1 value is less or equal to L2 value, at that time, I'm going to assign L1 to my head, and I'm going to say, now just go and now just move ahead. L1 equal to L1 dot next. I'm just saying move ahead. Once you assign to L1, now you move ahead, or I'm referencing that node to the next node. Now, if this condition doesn't satisfy, then what I said, else, in the else condition, I will be saying then otherwise assign the head to L2, and then L2 is going to point to L2 dot next. L2 is going to point to L2 dot next. This is called as merge to sorted list. This is the function which I have to call again, right? To the sub problems. I have to call to the sub problems. And basically, I will be calling to that two sub problems. And that is my head dot next, right? Because this is going to be, this is either this or either this going to be my head. So what is my head dot next will be? My head dot next will be the solved sub problem, which I showed you in the diagram. This is, let me, so this is the solved sub problem is my head dot next. This is my head dot next, which head dot next, which consists of this recall recursive function, which consists of recursive function. I will be merging it in my head dot next, and then I will be returning it to the head. So let's write that. So basically, I will be calling the same function to and assigning it to my head dot next L1 comma L2. And what am I going to return over here? I'm going to return the complete head. I'm going to return the complete head. Is this much clear? Is this much clear that whatever I'm writing this same I am repeating to a same function, I'm calling it again, and that is called as recursive approach. Now, one thing I wanted to let you know, like, what if we have to write some exception cases here? What if L1 is null? What if L1 is null? One list node is null, then what are we going to do? Then we are just simply returning the L2. If L1 is null, then we are returning L2. And what if L2 is null? What if L2 equal to null? If that is null, then we are going to return our L1. as our list note. These are just exception cases. Mostly, you can ask these cases to the interviewer while writing the code. If not, it is always good to mention the exception cases as well. And time complexity is big O of n plus n. Thank you for watching.